All right, so this video is going to talk about the attributes of a quadratic. So here we have a few equations, and so important things to be able to see are going to be the axis of symmetry, the vertex, the domain and range, and then what we call the roots or zeros, and I'll kind of add on to that. So I'm going to quickly graph this, okay, using Desmos. Okay, so that equation was y equals x squared minus 4x plus 7. Okay, and so what I'm going to do is grab a few points. Obviously, that's the vertex, and that's another nice, neat point. So I have 2 points, and I'll show you what's special about this. So let's go back over here. So 2, 3 is my vertex, so I can go ahead and write that over here. 2, 3, and I'm going to plot that point. So that's my vertex. And then I also had a point that was at, let's see here, 0, 7. 0, 7. Okay, and so I'm going to actually plot another point, and this is what's important, okay, is my axis of symmetry. And so this is something that all quadratic functions have, okay, because it's symmetric, okay? And so you'll see me abbreviate this AOS, just the axis of symmetry. So the axis of symmetry is basically a dotted line that goes through our vertex. And so this is the imaginary line that we have to kind of see in our head. If you can't see it in your head, then obviously you can graph it just like I did. Okay, but everything's symmetric around that point, and so that it will always go through the vertex. And so the equation of a vertical line right here of the axis of symmetry has to be x equals, right? And so then it's just going to be the x value of my vertex. So x is going to equal 2. Okay, and so that's how I know I have a vertical line at 2, because that's where the vertex is at. Now, since that's the axis of symmetry, anything on the left side, right? So I can draw this left side of the parabola and connect those dots. That's going to look identical to the right side. So if I know one side, then I should know the other. And so since I have a point at 0, 7, there's a point that's symmetric to that point directly across from it, or across the axis of symmetry. And so now I can kind of complete my graph. Okay, once I have my graph, then I can do the rest of this. Okay, so let's do domain and range. The domain, remember, the domain goes from left to right. So imagine this graph, this parabola is a road. If you're walking to the left, will you ever stop? The answer to that is no. You'll keep going to negative infinity. Same thing if you walk to the right. You're going to keep going to the right to positive infinity. So I have negative infinity to positive infinity. We say that is all real numbers. And so there's the symbol for all real numbers. The range, remember, goes bottom to top. Okay, bottom to top. So what's the lowest point on the y-axis that you will ever get? So here's the lowest I'll ever be. That happens when my y value is at 3. So we have 3. It is a solid line, so I'm going to have a bracket. And then if I'm walking up, okay, then I'm going to keep walking up forever. So that's positive infinity with parentheses. Okay, very important to know how to do domain and range. Okay, and then this last one, these two words are kind of different. Okay, roots and zeros, right? This has this has 4 different meanings. 3 most common are x-intercepts. X-intercepts are considered roots, which are also considered zeros. Sometimes these will also be your solution, but not always. Okay, so sometimes that'll be a solution as well. But for right now, just know for sure x-intercept, roots, and zeros mean all the same thing. So here it never intersects the x-axis, so there are no roots or zeros, so you just go ahead and put none. Okay. All right, let's move on to the second one. Again, I'm going to go back and change this equation now. Y is equal to negative x squared minus 2x plus 3. Okay, this time it's going opening down, so my parabola is opening down this time instead of up. And again, the first point I start with is my vertex, so negative 1, 4. So negative 1, 4. I'll go ahead and plot that one. There's my vertex. When I have my vertex, I should know my axis of symmetry. X is equal to negative 1. You do have to write it this way. You have to write it as an equation because that equation is going to create the line of my axis of symmetry. Okay, so the line of my axis of symmetry is x equals negative 1. Okay, then I go back and I look at the other points I can graph. So I have a point at 0, 3. So I come back over here, plot a point at 0, 3. If I have that point on this side, then I know I should have its image directly across the axis of symmetry. Okay, and then I also have this point 1, 0. So I can also plot that point, and then it's directly across the axis of symmetry. Okay, and that's probably as many points as you need. I'm going to do one more just so you guys see what else I can do. So notice I don't have any other points down here, right? I can kind of click and drag on this, but if I want to, I can make a table out of this. Okay, so I hit this little cog or gear, and then I hit convert to a table, and then this will show me, obviously more points. And so here is another nice neat point at 2, negative 5. So 2, negative 5 is there. And then I have a point directly across from it on the axis of symmetry. And so now I can just simply connect the dots, draw my arrows because this is going to continue on down. And that's what my graph looks like. Let's find the domain and range. The domain, again, if you're on this road and you're walking to the left, how far left do you go? Negative infinity. Walking to the right, I keep going to positive infinity. So again, the domain is all real numbers. You should see a pattern there. The range, how low do I walk? So if I'm going down, I'm approaching negative infinity. To how high I go, well, the highest point is up here at the vertex, which is at positive 4. So it goes from negative infinity to positive 4. Whoops, that should have a bracket. So we can write it that way, or we can simply say y is less than or equal to 4. Okay, so either way. And then I'm looking for my roots or my x-intercepts, also known as zeros or solutions. So where are my zeros? Those 2 points right there. So I can write this different ways. I can write them as an ordered pair, right? I can do negative 3, 0 and 1, 0. So I could write the answer that way. If I wanted to, I could use the bracket, this little squiggly bracket, and then just put the x values in order and close the squiggly bracket. So that also is another way you could write that. All right, and then the last one, y equals 8x squared minus 2x. Okay, I'm going to zoom in just a little bit because it's super tight. Okay, this time, not very nice and neat, right? So we have like really small decimals. So that's going to be kind of hard to graph. If you wanted to, you still could. We have vertex at, oh my gosh, 0.125. So 0.125. It's kind of hard to do that. And same thing for the negative. I mean, you might have to really stretch that. I don't really like this example too much. All right, but you kind of get the idea here. It's super small. You could extend it more if you needed to, but you kind of get the idea. So the main thing is we want the vertex 0.125 negative 0.125. That makes my axis of symmetry. X equals 0.125, right? And then my zeros, my roots, my x-intercepts are 0. So I'm just getting the x value and 0.25. 0.25. Okay, my domain is still all real numbers. And then my range, the lowest value is negative 0.125. I grab that from my vertex. And then the high value is positive infinity. Okay, so those are just the attributes of a quadratic and what it should look like. And then we have some factoring problems here. So we should be really good at this. So I'm going to factor number 4. It does say solve, so I'm going to actually find the values of those two factors that I find. So remember, the product goes up top, the sum goes on the bottom. Two numbers that multiply to get 32 that will sum to get negative 12 are negative 4 and 8. And so I know that x equals a positive 4 here and x equals a positive 8 there. So those are my two solutions. Okay, also known as x-intercepts, roots, and zeros. Okay. Number 5, same concept, except I have to bring the 15 over to the other side. So my new equation is going to be x squared plus 8x plus 15 is equal to 0. Now I can factor 15 and 8. 3 and 5 are the two numbers that satisfy that. X plus 3 times x plus 5. That means x has to equal a negative 3 or x has to equal a negative 5 for that to be true. Again, these are known as my x-intercepts, zeros, roots, or in this case, solutions. All right, and then number 6, we do have to subtract 3x to both sides. So that leaves me with x squared plus 2x minus 35 is equal to 0. Negative 35 up top, positive 2, that gives me 5 and negative 5 and 7. X minus 5 times x plus 7. So x has to equal a 5 or x has to equal a negative 7. Again, that's my 0, that's my x-intercept, that's my roots. Those are my solutions.